Graph the following function and its reciprocal. Give the domain and range for both. Give equations for any asymptotes. Here, the original function y equals f of x must be graphed first. In this case, it corresponds to a quadratic function that is represented in vertex form. F of x equals a times x minus p all squared plus q. In this case, a, the vertical stretch factor, is equal to -1, and p comma q, which corresponds to the vertex of the parabola, equals 2 comma negative 0.25. We then draw the graph of the reciprocal function. For each point x comma y on f of x, the point x comma 1 over y will be a point on the reciprocal function. The domain is the set of possible x values, and the range is the set of possible y values. Vertical asymptotes will have the form x equals c. The horizontal asymptote will always be y equals 0. First of all, let's look at the original function y equals f of x. The vertex at the point 2 comma -1/4. The a value of -1. This means that the graph opens downwards and is congruent to the graph of y equals x squared. This means that as we go over 1, either left or right from the vertex, we would go down 1. As we go left or right by 2 units, we would have to go down by 4 units. We then have the graph of our original function, a parabola opening downwards. As for the domain of f of x, recall that the domain for any quadratic function is the set of all real numbers. As for the range, in this case we have a parabola opening downwards. This means that the vertex corresponds to a maximum value. We then have a range of y less than or equal to -1/4. Note -1/4 is the y value of the vertex, and y is an element of the set of real numbers. Moving on to the reciprocal function. First, we will note any points for which the y values are either 1 or -1. These are invariant points which will be the same on the original function as they are on the reciprocal function. In this case, we have 2 invariant points, both corresponding to y values of -1. We'll then look for any y values of 0. These correspond to x-intercepts on the original function. In this case, because the vertex is below the x-axis and the graph is opening downwards, there are no x-intercepts. This means there will be no vertical asymptotes for the reciprocal function. I will now plot 3 additional points on the reciprocal function by taking points on the original function and taking the reciprocal of the y values. First of all, looking at the vertex. The vertex at 2 comma -1/4, taking the reciprocal of -1/4, we get the point 2 comma -4. The original function also has points at approximately -1/2 comma -6 and 4.5 comma -6. On the reciprocal function, these correspond to approximately -1/2 comma -1/6 and 4.5 comma -1/6. We then have to connect the points. being aware of the horizontal asymptote of y equals 0 corresponding to the x-axis. As for the domain and range, first of all, the domain corresponding to the possible x values, since there are no vertical asymptotes, there are no restrictions on x for this function. We therefore have x is an element of the set of real numbers. As for the range, note that the minimum possible y value corresponding to the vertex of the original function is at -4. We also have to pay attention to the horizontal asymptote at y equals 0. We therefore have a range of -4 less than or equal to y less than 0. And y is an element of the set of real numbers. As for asymptotes, again, there are no vertical asymptotes because the original function did not have any x-intercepts. We do, however, have the horizontal asymptote y equals 0.